Hello everyone. My name is Kyungbe from Posttech, and today I'm gonna introduce about my paper Diffusion-C, Unveiling the Generative Challenges of Diffusion Models through Corrupted Data. Deep learning have shown remarkable performance in various domains, but they are fundamentally vulnerable to adversarial attacks and various corruptions. Deep learning is significantly affected not only by substantial and critical noise, but also by minor deformations. Here's some examples about vulnerability of deep learning when it trained on adversarial attacks in here. Diffusion models, which is the science of noise, has proven its prowess in creating top-tier images and garnered significant attention, leading to numerous studies exploring its inherent boundaries. So, in this study, we determined to observe the specific disturbance to which the generative models are susceptible and their respective magnitudes. In this paper, we used Diffusion-C. So, what is the Diffusion-C? It is a methodology of adversarial attacks on diffusion models to evaluate how changes in input values influence output value shift. So, through Diffusion-C, we want to solve these three questions in here. The first question is if the original input is corrupted with the corruptions, can diffusion model still return quality images? So through this first question, we want to watch that which corruptions the diffusion models are vulnerable to. Second question is how much can fog degrade the performance of the diffusion model? And the third one is are diffusion models vulnerable to fractal structures? First, in these first questions, we used 8 corruptions. Based on the clear version, we used 7 corruptions in here. So we used shot noise, impulse noise, glass blur, motion blur, brightness, fog, and spatter noises. And we trained it on these we trained the diffusion models with these corruptions, and to compare we used DC gain and resistant gain gradient penalty. So as a result, uh, we can uh, we can conclude that the diffusion models has a superior performance than other generative models. In this graph, the blue one is the DDPM, and orange one is the resistant GAN, and the green one is the DC GAN. So, through this graph, we can watch that the FID score of DBPM is much lower than other ones. And uh, diffusion models are vulnerable to fog corruptions. Uh, so, and the second question is how much can fog degrade the performance of the diffusion model? Actually, the purpose of this research is to find the generative drawbacks of diffusion models. We proceeded this second one. So, using fog, to which diffusion models are vulnerable, experimental designs incorporated 5 tiers of fog severity across 5 datasets, which are MNIST-C, Fashion MNIST-C, Cypher 10C, Cypher 100C, and the Tiny ImageNet-C. So, through the second question, we assessed the degree of performance degradation as severity increased. As a result, actually there was no significant concern on the results. And DBPM and DDIM susceptibility to specific corruptions, which is for corruptions, is notably shaped by topological and statistical congruence, especially the correspondence between mean and variance, which is similar to fractal structure. Fog corruption is generated by a diamond scale algorithm which has characteristics of self-similarity, and it is similar to fractal structures. So we delved deeper into the fog corruption, rooted in the theoretical plasma fractal that showcases self-similarity traits. So We hypothesized that diffusion models might encounter challenges when trained on images with fractal structures. And as a result, neither DBPM nor DDIM demonstrated significant vulnerability in generating images with fractal patterns. As a result, we concluded three conclusions in here. First, diffusion models have superior performance than other generative deep learning models. And second, within the vast spectrum of corruption frameworks, the fog and the fractal corruptions notably undermine the functional robustness of diffusion models. And last, the vulnerability of diffusion models to these particular corruptions is significantly influenced by topological and statistical similarities, particularly concerning the alignment between mean and variance. Thank you for listening to my presentations.